Hi everyone, in this video we will talk about FET transistor. What is FET transistor? FET transistor is also known as a field effect transistor. It is a type of transistor commonly used in both analog and digital circuits. It is distinguished from other types of transistor by its principle of operation, where the electric field effect is used to control the electrical behavior of the device. There are two types of FET, which is JFET and MOSFET. JFET are the simple type of FET and are usually used in low noise amplifiers. The gate is formed by a PN junction, hence the name junction FET. MOSFET are the most widely used type of FET, especially in integrated circuits. A MOSFET features a metal gate separated from the semiconductor by a thin layer of insulting material, which is typically silicon dioxide, hence the name metal oxide semiconductor FET. Moving to the basic structure of FET. Generally, FET consists of three parts: source, drain, and gate. The source is the part where current enters, the drain is where current leaves, and the gate is the control terminal. The part where carries in the electron or holes are injected into the device. The source is equivalent to the emitter in a BJT. Drain is the part where carriers leave the device. Drain also equivalent to the collector in a BJT. Gate is the control terminal. By applying a voltage to the gate, the current flow between the source and drain can be regulated. Next, moving to the operation of FET. The operation of FET is governed by the use of an electric field to control the electrical conductivity of a channel. This is accomplished by applying a voltage to the gate terminal, altering the distribution of charge carriers in the channel and modulating the current flowing between the source and drain. When a suitable voltage is applied to the gate, it creates an electric field within the transistor. This field influences the charge carrier distribution, thereby controlling the current flow between the source and drain. The higher the voltage applied, the more the current is allowed to flow. As you can see here, this is the symbol of FET.
Junction field effect transistor (GFETs) have two main structures, the N-channel and the P-channel. In an N-channel GFET, a semiconductor bar of N-type material is connected to two regions of P-type material forming a PN junction. A voltage applied across this PN junction controls the width of the conducting channel, affecting the current flow. Conversely, in a P-channel GFET, a semiconductor bar of P-type material is connected to two regions of N-type material, creating a PN junction. Similar to the N-channel GFET, the width of the conducting channel in the P-channel is controlled by the voltage applied across the PN junction. Both types operate based on the voltage applied to control the flow of current through the channel between the source and the drain terminals.
What is JFET characteristic? JFET characteristic is plotting a curve between the drain current and drain source voltage defines the characteristic of a JFET. Its characteristics are defined as the fluctuation in drain current with regard to the voltage delivered at the drain source terminals while maintaining a constant gate source voltage. P-channel JFET characteristics, also known as output or drain characteristics, and transfer characteristics are the two main categories of characteristics. Okay, now we will go to P-channel JFET characteristics. Since there is no external reverse biasing, in this case, as there is no voltage between gate and source terminal, thus the drain current will flow from drain terminal to source terminal. The channel width is larger because the depletion layers width won't change initially. The N-type channel will act as a resistance area in this situation. The voltage drop between the gate and source is caused by the current flowing from the drain to the source. The gate source terminal gets externally reverse bias when the external bias is applied to it. In contrast to an unbiased circuit, we can obviously reach the pinch-off point much sooner if we are applying an external voltage. The external bias characteristics curve makes this very visible. Variations in voltage result in variations in current values. It is important to keep in mind that the gate source voltage should remain constant while analyzing the drain characteristics in relation to variation in the drain source voltage. Now we will go to transfer characteristics. In this graph, the transfer characteristic of input to output is not as straightforward in a JFET as it was in BJT. In BJT, beta indicated the relationship between IB, which is input, and IC, which is output. In a JFET, the relationship of VGS and ID is a little more complicated. As you can see in this formula, ID equal to IDSS open bracket 1 minus 2 VGS over VP close bracket and square. From this graph, it's easy to determine the value of ID for a given value of VGS.
Calculation for junction field effect transistor. This question, one with to determine the values of VGS, ID, or drain current and VDS for the circuit. As we know, VGS is the minimum gate to source voltage, ID is drain current, and VDS is maximum voltage between drain and source. Since there is no gate current, there will be no voltage drop across RG, gate resistance. VGS equal to VGG equal to negative 10 volt. Now, to calculate drain current using formula ID equal to IDSS times in bracket 1 minus VGS over VGS of close bracket square. It will be 16 milliampere times to 1 minus negative 10 over negative 8 square. And the answer for the drain current is 1 milliampere. Next, to calculate VDS, we use formula VDS equal to VDD minus ID times RD. It will be 10 volt minus 1 milliampere times 4.4 k ohm. Then the VDS we will get 5.6 volt. Note that operating point for the circuit is 5.6 volt and 1 milliampere. So that's the answer for our example calculation. So that's the end for our FET transistor presentation topic. Thank you.